Thank you guys for having us. It's going to be a blast. We've got 3 topics for you today, all around continuous delivery, and 3 presenters, so it's going to be awesome. And I'm Szczepan Faber. I live in Silicon Valley. I came here all the way for Confitura, and I hope you'll enjoy this presentation. Do you like making releases? Do you like to make those decisions whether to include a feature in the release or not? Or the decision points around, are we ready to make a release, or we need to cook that beta version a little bit longer, or that release candidate? And release notes. How many of you likes writing release notes? No, like you shouldn't. That's an overhead, and we shouldn't have to do that. That should be completely automatic. And this is the story about it. We'll start with the Mockito journey to continuous delivery. So in 2008, Mockito was a small library, and small library has small problems. It was essentially one guy writing all the codes and doing releases manually. That was 2008, so it was a time of checked-in jars. Like people were, there wasn't Maven. I mean, Maven was around, but nobody used it at that time. And Mockito got this problem, which is an awesome problem to have, and I wish you guys to have all that problems. It got popular. So releases were more troublesome, and it was more overhead, more contributions, more use cases, and that's awesome. You like more use cases because then you can grow the library, but then it introduced that overhead, and basically we started releasing Mockito every 2 years, which is sad. Nobody should be releasing every 2 years. That's way too long. And Mockito is really popular. So this is the data from 2016. Many projects on GitHub were scanned, and you can see that Mockito is pretty high on the list of one of the most popular libraries used. So you wouldn't believe why Mockito releases were procrastinated, mainly by me, and why we released so rarely. So here's the story. I knew that to build the community, we need to really and truly appreciate the efforts and contributors. And the best way of doing that is to making sure that there's a really good changelog. We mention all the contributors by name. We actually write down what are the good things they've added to the release, and also release frequently. Because if somebody contributes code and commits his own free time to work on our open source project, that's awesome. He could be doing other things, binging on Netflix or hanging out with buddies, but no, he's working on code and helping out with the open source community. So we've got to be appreciative. I learned a lot about that from Dan Ariely. He's not in software, but he's the scientist around the behavioral psychology and what motivates us, and I definitely recommend you to read that. So I needed to write really great release notes for Mockito, and I hated doing that because it was, I guess in my brain, it wasn't really engineering exercise, it was more like promotion. So instead of doing that, I postponed, and the more I postponed, the more features were there, and basically a vicious wheel, more procrastination. In 2014, I said, that is not sustainable. The library will essentially die because there are no releases. And I decided that I will never, ever procrastinate Mockito release again. And you know how easy it is to say that. I will never smoke again, I will play with my kids and not work. Or this is most humans on planet Earth say that thing to themselves at least once in their life. I will never drink again, right? So I knew that in order to avoid procrastination of Mockito releases, I need to eliminate all the reasons to procrastinate. So this essentially entire process around releasing Mockito has to be automated, and there are no decision points in that process. Basically, stuff gets out and stuff gets released, so long the pull request, the change that we are about to merge, is high quality. It has tests, it solves some problem or introduces the behavior that is desired, that is good, that is within the mission and within the Mockito spirit. And if it's good, we merge that pull request, a new version is out in Maven Central. And let's look at some of the pros and cons of that approach that we have learned over the couple of years of doing that in Mockito. So let's start with the bright side and focusing on the open source. I don't have to spend any time on making releases, because this is all automated. I just need to validate if the pull request is good, give feedback. Or maybe this is good enough and I just merge it. I have happy users, hopefully, because they get features really fast. Debugging is faster because it's easy to pinpoint the version that introduces any regression. And then, since every change has very little change is pretty small, usually it could be even one commit, then it's easy to find the commit that actually broke. So the time to resolve is really small, which is nice. It's also helping with sustainability, and it's very critical for open source projects. Like the fundamental reason why open source projects die is because there are no releases, right? With that model, so long you have somebody who can review and merge a pull request, you're good to go, your project will leave. There's no unreleased code, because all code is released. Like unreleased code is a waste. Like you don't know if it works because nobody uses that. Like don't have any unreleased code. Oh, this is the one that I love most, and I'm not sure why it's at the down of the list. So it creates this like self-enforcing mechanism of like high quality, because at the point of merging the pull request, I gotta make a decision whether this is good, whether not only the use case and the design is good, but also the tests are there, documentation is there, like everything needs to be sorted out before the pull request is merged. You don't have that luxury to postpone that, to do that later. Like, you can't just, let's do the release notes later, like when we are closer to the release. Let's do the documentation later. Or the worst of that, let's write the tests later. It's fine, you know, it works. I've tested it. Also, it helps you build really thriving and engaged community. It's really cool when somebody submits pull request, and if it's working, you merge it, and it's already there. He can take advantage of that, as opposed to the situation when there is a pull request, and even if it's merged, someone has to wait years before it gets published, which is not good. Now, not everything is like so beautiful. We got some feedback from community. So, what are the concerns raised by the community with that model? So there is this quality anxiety. Like you release all changes to production all the time, even at the level of individual commits. So you'll be releasing bugs at the same rate, which is, you know, I don't want bugs, I just want useful features. So, and the best way to address that anxiety is to write high quality stuff, high quality code. Make sure that the code is reviewed, make sure that the code has tests and everything. That's the only way we can. Actually, we solved that differently in Mockito. In Mockito team, we decided that we will never ever implement any bugs. So that's actually something you could try out yourself as well. Another concern that was raised is what version to use. There are like 200 or 300 Mockito versions by now released to Maven Central. So it's a lot. And folks are worried, like, which one is the best? Like, what is the most stable version out of them? The answer is usually easy. Say, latest, always the latest. Now, it's kind of hard to resolve that concern. In continuously delivery model, like it's unavoidable that there will be a lot of versions. That's just how it works. And the only way to solve it is to make sure that those versions are good. They are compatible, you don't break compatibility often, preferably never, unless there is a conscious incompatible change where you want to do major version release. So that's the only way to solve it. Finally, users reported that frequent versions also introduce this extra dependency management cost, which is a valid concern. Like, let's say you are an author of a library. So every dependency of that library is an extra liability to your customers, to people who use that library. Because they have to manage eventual version conflicts if they also use some of your dependencies or your transitive dependencies. To address that concern, you basically do high craftsmanship. You make sure that you understand what are the dependencies that you are pulling in. You are conscious when you are bumping your versions of your dependencies because that will have effect on your customers. Like Mockito will never depend on Guava because Guava is just too big, and also they have much more frequent cycle of major version changes, unlike Mockito. So those are the considerations that we are taking whenever we're doing anything with dependencies. Another solution to that could be shading all the dependencies, which has another set of disadvantages. I don't want to get too much into that. Those are all valid concerns. They can be addressed, specifically by applying high craftsmanship. Now you can use a tool called ShipKit. ShipKit is a toolkit for shipping it. It's used by Mockito library, and currently it's a set of Gradle plugins and also libraries that you can essentially drop into your Java project and things will work. You can adopt the same style, the same continuous delivery pipeline as Mockito. We'll show in a second how easy it is to configure ShipKit, but that's Wojtek, who's going to take over now and tell you more about ShipKit and demo it. Go for it.
So this is how ShipKit works. It is always initiated by push to master, usually by merging a pull request. Then GitHub, through a service hook, starts a Travis build, not only a regular Gradle build, but also it runs a few ShipKit tasks that will bump the version, update release notes, and push it all to master. And afterwards, all the build artifacts are published to bin tray. And if you have some Java code, how can you use it with ShipKit? So I prepared a simple Gradle Java project with a basic configuration. So here is our build Gradle in our root of the project. I will add a ShipKit dependency here. And now I will apply a ShipKit plugin. This is all we need to do for now. And now when we go back to the terminal, we can run Gradle Tasks because ShipKit doesn't break configuration phase of your Gradle build. So we have a lot of ShipKit tasks here, but the most important one at the moment is init ShipKit, which generates all of the configuration files that you need at the beginning. So we will run this task. And you can see in the log that there were a few files generated, and for better readability, we will see it with git status. So there's Travis YML, which contains all the tasks that Travis will run on CI server. There is ShipKit Gradle that contains all the ShipKit configuration. So there is bin tray and GitHub configuration and some other things. And there is a version properties file that basically contains the version that will be released the next time we want to release. And the great thing about ShipKit is that it doesn't require more than that just to play around and test it. Because if you don't specify any GitHub token that would be used on the CI server, ShipKit will use your Git configuration, your local Git configuration, and in case of bin tray, ShipKit provides you with a playground repository. So if you want to just play around with ShipKit, you can just run a task like CI perform release in terminal, and it will do all of the things that I mentioned in workflow. So CI perform release is a combination of few ShipKit tasks. First of them is assert release needed, which basically just tells if the release is needed at the moment, if there is anything interesting from the client perspective, and if we are on a proper branch to release. Then there is a CI release prepare task that sets up Travis Git configuration. So it checks out the proper branch, and also it sets a few properties like user email or username. And then there is the most important task, perform release, that does all of this significant stuff, like bumping version file, updating release notes, committing all of these changes, then running a regular Gradle build, tagging version, and at the end, it pushes it all to master, as I said, and uploads all of the build artifacts to bin tray. And now when we go to GitHub, we can see that there was a commit made by ShipKit in this repository. And if you open it, we can see that release notes were updated, and also version was bumped. Because version properties file is generated by init ShipKit based on your current Gradle version of your project. If you don't have any version specified, it will be first semantic version, which is 001. And in this case, you can see that it was bumped to 002. Now, if you go to docs release notes, which is the default path of release notes in ShipKit, we can see a nice generated release notes of all the pull requests that were taken into this release. And now, if we click on this bin tray batch here, we can see that artifact was deployed on bin tray. Also, for better readability, I prepared a pull request that contains all of these generated files by init ShipKit task that I just ran. So here's Travis YML that runs a regular Gradle build just to check if the code compiles and if all the tests are passing. And then if it succeeds, it runs the CI perform release, the task that I just ran in terminal. There is also the ShipKit Gradle that contains, as I said, GitHub configuration and also bin tray. Here is this bootstrap repository of ShipKit. And there is also this version properties file with default version of 001. So if you want to run, this is all you need to run ShipKit just to play around with it. If you want to run it in production, you need to do a couple more steps, but it only should take you a few minutes. So first of all, you need to create a bin tray account and add a new repository. And then you need to connect your GitHub project with Travis. And this is done by authenticating on Travis with GitHub and also clicking a button like that. There is only one more step, setting variables like bin tray API key and GitHub write token. And the best and the safest place for that is Travis. And it is easy, like you see that. And another great thing about ShipKit is that it doesn't log your GitHub write token at any time in Gradle logs. It is always replaced with something like here, secret keyword. So now Marcin will tell you more about other features.
Okay, thank you, Wojtek. My name is Marcin Stachniuk, and I will talk about a little bit more about ShipKit features. And I ship every commit to production, because if you write the code, it's a null till you ship it to production. And for me, the most important, the most powerful feature of ShipKit is this release notes. I suppose that you probably don't like prepare release notes. I mean, copy the tickets from the Jira or GitHub issues, paste to the GitHub markup or wiki or Confluence page, and send to the all stakeholders, project stakeholders. I like to prepare release notes because with ShipKit it happens automatically. And this is important to have in your projects, to have release notes, because I think this is important for the end users to know when some feature was introduced. This is a real screenshot from the Mockito project, and you can see here that the version, the date of release, number of commits. If you click here, you can see all the differences between releases, who made these commits, and link to the bin tray where we can download our library. This is yet another example of release notes. This is from a different project. And release notes are for us really important because of the second reason. Because as you can see here, there are the names of the contributors, and these names are linked to the GitHub profile page. And we think that this is the best way to say thank you to the contributors. And you can see here also the labels, for example, Java 8, new feature, documentation, and everything that we can get for free from ShipKit. Because on the GitHub page, with the pull request, you can label your pull request, and later define in the configuration how to map this label to the text here. How to generate release notes. We have a task, update the release notes. For that, we can run them with the p-preview flag. Then the output will be printed to the console output. Without this flag, the release notes file will be updated. The next thing, if you upload your artifacts to the Maven-like repository. I mean Maven Center, bin tray, Artifactory, or whatever else, we also need to generate Pom file, Pom XML. Why? Because there are information about another dependencies of our library. And I know probably nobody of you didn't read these files. I think that probably people from Maven Central read this file, but there is also a section to the put contributors there. And this is yet another way to say thank you to our contributors, because we appreciate each contribution to the project. When the new version is published, so we have a couple of checks. First of all, during preparing releasing new version, we check if skip release environment variable exists. If it exists, we just not shipping new version. It can be useful if you want to try ShipKit on your Jenkins instance. In Mockito, this is also really important because Mockito is compiled against a different version of Java virtual machines. And we can ship from all this build a new version. We can ship only from one of this build a new version, and for that we use skip release environment variable. We also check the commit message. If the commit message contains CI skip release, then we also skip the release. We also check if the Travis built a project from the pull request or not. If it is pull request, we also don't ship to production. We also check the branch name because we should ship new version from the master or from release /2.x because this is default branch, for example, in Mockito. And the last check, we also compare the changes in production code. How it works, just during preparing this release, we download a previous version of the source code and the previous POM, and we compare them with the current version, with the current state. Why this is useful? Because if we add a new test and didn't change any production code, or if we fix some typo in the README or update the documentation, there is no reason to ship new version to the Artifactory. What else? ShipKit also works with the GitHub Enterprise. If you use GitHub in your company internally, we can use like the normal GitHub.com. And what are our plans and goals for the future? We think that the ShipKit should be simple and easy to use, and we try to achieve this goal. Because if you think about the normal products, not for the developers, the companies hire a lot of user experience designers and try to make their products really simple and easy to use to their end user. Because if not, they will be lost and startup will don't get the success. With developers tools, this not works like that, because developers can read the code, can read the documentation, can ask on the Stack Overflow, and these tools are not, I think, good enough. The quality is not so good. We don't think so. We think that the tools for developers also should be simple, as easy to use, and That's the reason why we have a lot of smart defaults. We're thinking about introducing some release notes templating. We want to add a support for other services than only GitHub and Bintray. We want also to publish to the Maven Central directly without any Bintray. We also think about introducing, we started implementing that end-to-end test and A/B testing with the penders. What that means? We want to verify our library against the projects which use, in this case, ShipKit. For example, after the end of the build, we try to clone Mockito, bump a version of the ShipKit, and compare the results of the outputs from these two builds. If everything looks okay, we want to create a pull request to the Mockito with the new version of the ShipKit. We also want to support Gradle plugins authors to ship plugins to the Gradle Artifactory. And we also want to release libraries to the GitHub releases. Here is the link, here is the tab where we can find that. Not a lot of people knows about this feature, but we can also upload our binaries to the GitHub. So if you want to join our team, we use this label please contribute on the GitHub issues page. These issues are usually easy to contribute, easy to write the code, and they are well scoped. So the description is very long. There are links to the code, where to start, and stuff like that. So it's easy to start working with the ShipKit. And as you can see on this diagram at the bottom, we produce a lot of code. So yeah, please join us.
Let's go from open source to the real world, continuous delivery in the enterprise based on LinkedIn. So I'm tech lead for development tools at LinkedIn, and we are very close in the development pipeline and the workflow that is used from commit to production. How does it work at LinkedIn, and how do we do continuous delivery? So all the benefits of continuous delivery that we have mentioned before for open source, they also apply for enterprise cases, and especially like those enterprise, like large-scale applications and organizations. Now, there is some extra stuff here as well. So you also get this rapid innovation. Because it's really short time from commit to production, like you can even shrink it to even a couple of hours, even for large-scale applications, you really can test your business product theories fast and get immediate information from your customers whether this is useful or not. You can monitor. So that gives competitive advantage, and that's a fantastic thing you can get when you start making those releases like more frequent. Let's say you release every 2 weeks, try to release every week, for example. And at LinkedIn we have that acronym called 3x3, and it stands for an initiative that we have started in 2015. It applies mainly to the LinkedIn.com, the main, we call it flagship application. LinkedIn is big enough that we have like multiple products and multiple applications. And those different engineering teams, they apply sometimes like different flavors of continuous delivery and 3x3. But 3x3 is like the big thing. It applies to our biggest, most important application at LinkedIn. And 3 hours is the maximum time from commit to production. We created that narrow window, and we had to come up with the technology and also process everything to make that happen. This is very interesting. Now, we knew that it's not possible to do all the testing within 3 hours. Like think about regression testing, performance testing, end-to-end testing, all those kind of testing to make sure that your application is really high quality. And for an application of scale of LinkedIn, where we have 500 million members now, like, it's not possible. You gotta figure out how to test stuff. And it means that we will do less testing of certain components. You heard Jakub Kubrinski, test only the critical path using your end-to-end tests. Also, what we do is we do a lot of monitoring. I'll tell more about it soon. We also do a lot of testing at lower levels to make sure that those tests are typically faster, higher, easier to maintain than end-to-end tests. And that 3 hours maximum time, it creates a constraint that enables many good things at LinkedIn. We also do 3 releases per day. And in our case, we found it insufficient to just be ready to release with every commit. We actually do releases three times a day. Like, we really do it. We were worried that if we just create the capability to release as frequently as possible, even multiple times a day, that would be an insufficient forcing function to have really high quality change at the daily basis. We knew that the best forcing function is actually doing those releases, because then, like, every single change that goes in and goes through the build pipeline has to be really high quality. And that's what we do. And so continuously delivery is hard. We found out, we implemented 3x3 in 2015, and we've stumbled on many issues, and I will tell about them all. And what do we do if something is hard to do? You tell me, what do we do? And do it more often, exactly. So I've learned that first from Jess Humble, one of the co-authors of Continuously Delivery, and that's a great advice for everything, not only IT, for life as well. If something is hard, do it more often. So we wanted to do it more often, like 3 times a day. Now, the problems that we have stumbled on. Flaky test is worse than no test. Like, that was one of the favorite saying of engineers at LinkedIn who were working on the flagship app in 2015. If you have really large team and you have high stakes, like, flaky tests are really killing you. It's really something that you have to deal with. In small team, fixing a flaky test that fails once a year probably has little value. You can live with that, it's okay. You can just restart the build, it's fine. In an organization like LinkedIn, where at certain time we had over few hundred engineers working on the flagship application and different components of that application, because there are multiple layers. The architecture is pretty complicated. We can't have any flaky tests. We addressed that by creating a system that runs all those tests every night 1,000 times. And I tell you, if you run one test 1,000 times without any code changes, just run the same test, you will identify pretty easily if it's flaky or not. So we have that system. When flaky test is identified, the Jira ticket is opened. That test is immediately taken out of the test suite because it cannot block any engineer, it cannot block any build. When the build is broken for the flagship team, it's a really big thing. That cannot happen. People are called, that cannot happen. Another thing, we found that the testing and the infrastructure has to be production grade. And it really means that typically, what happens is production code is of the highest quality. Usually tests are a little bit lower quality, and the infrastructure, the building blocks, the build files and stuff is just basically let's just put things together so that it works. So let's say that's the average style, hopefully not for your organization, and hopefully it's changing. Now, we discovered that every of those components have to be production grade. It has to be really high quality. And we apply the same levels of craftsmanship to all those places. And it was hard to do. It's you have that 3-hour window, right, for doing all your testing, all your validation of your application. We eliminated completely any kinds of manual validation of the release. If you automatically release 3 times a day, there's no way you can squeeze in any manual process that somebody has to bless the release and sign it off. You can't have something like that. Everything is automated. So you got to figure out how to write tests in the best possible way. And hopefully you learned from other presentations at this conference how to do it. Testing pyramid, when to test, how to test. We've learned that lesson too. We found best ways to test the layers of our application. And that took time to adopt those new ways of testing and make it good. Many years ago, at LinkedIn we had like QA engineers that would be validating that whether the application is working. In the current 3x3 model, there's zero manual testing, so there's no QA at all. No QA, no like testers in a sense of somebody who would be manually validating the application. Like, of course, QA exists, quality assurance and high quality exists. We found that open source frameworks are too slow, especially for mobile platforms, and we had to like pretty aggressively fork all various components available in the open source, fork them, fix them, make them fast, make them more reliable. If something runs on one simulator, make it run on 20 simulators. We needed really fast execution of tests, not only stable. So we heavily parallelized, we heavily distribute the test suites. Another lesson that we have learned is that the master branch has to be always green. It's very important for a large team with high stakes. In a small team, if the build is broken, yeah, I'm going to fix it after lunch. Something like that works. It's probably not a big deal. In a large organization, that's really like big team. It's really like you can't, it's blocking. Like it's basically people are wasting time and they are not productive. So the trunk is always green. And the way we have implemented that, basically we put all the validation up front. So before the code gets merged to the main branch, it's going to go through all the testing, all the validation. And this one more very important component of like how LinkedIn was able to roll out 3x3 and create that engineering culture of continuous delivery. So we have at LinkedIn pretty sophisticated developer workflow. This workflow applies to every technology stack. And we have about 5,000 projects, various kinds of projects. Some of them are like small Java libraries to some mobile applications, through some C++ native code, like all kinds of stuff. And for every of those technology stacks, every team basically uses the same workflow. So I want to go through that workflow really quickly because this workflow is important to push for high quality and effectively be this very important component of making continuous delivery possible. So first there's a code change, it's cool. There is an engineer, hands on keyboard doing stuff, awesome. The next thing is code review, and at LinkedIn code review is mandatory. Like the teams cannot like opt out, we good, we don't make bugs, everything works, we don't need code review. So that's not how it works. And every code change has to be reviewed by somebody else. And that's pretty awesome. I love those kind of things because it really created over the years this engineering culture where it's based, like code review is just part of your process. You review code every day of other people. It also makes it easy for contributing to other teams because you know what's the process is the same, you know where to find the code, you know how to submit code for review. Every team uses the same style, the same tools for doing code reviews. So that worked really well for LinkedIn. And actually, you can tell me, what is the only one better way than code review to ensure like high quality? Excellent, pair programming. So if you are disciplined, actually I have a question. So how many of you in your organization do disciplined pair programming or disciplined code review? Like how many? Give me a hands. Awesome, it's like a half of the people. Okay, cool. Let's move on to the next subject. You are sold already. Awesome. Then we do, after the code review is shipped, we call it ship it. You know, if the change is good, we ship it. There is pre and post push validation. I'm making separation between pre and post because teams can configure what happens before the code gets merged to the main branch and after. We have some sensible defaults. Some teams prefer to do all the validation before. Some teams do most of the validation after. And that's how we do it. Think about this pre and post validation as just continuous integration pipeline where you have Travis or Jenkins that will do building. Oh, and number 4 is very interesting. So this is the Pender Testing. And as far as I am aware, such concept does not really, there are no tools for that. And how it works. Basically, at LinkedIn, we have automated validation of everybody who depends on your changes, right? So if you're working on that component and you have a change to that component, and that change goes through the pipeline, we will automatically run all the projects that depend on that change on that software component that you're building. So like test all my dependers. This is really cool, and this is fully automated. At LinkedIn, this is a strong signal to the build pipeline. If I broke one of my consumers, like I will not publish a version. That's, it's a stopper. By the way, I know that I have like 4 minutes left, so I'll do like 5 minutes later. So I'll delay a little bit my answer. It's gonna be all good. Now, when the dependent testing is successful and everybody's happy, all your consumers are happy with your change, we publish new version. That's also something very like interesting and not in the traditional way of like doing software. In a traditional way of doing software, like developers are making changes and changes they accumulate on the main branch, and at some point, hey, let's do the release. So they select a version and they publish a new version. So that's not how we do it at LinkedIn. At LinkedIn, every new version, every code change that goes through the pipeline will produce a new version. And for libraries, that is almost the end of the life cycle of the library. Now consumers will be able to consume that new version. And at LinkedIn, we also have ways of automatically like pushing your upgrades to your consumers. At LinkedIn, we have tools that tell us what is the dependency graph, who depends on me. Also, we have ways for the consumers to depend on the latest version of your library. So all that stuff we have tools for. Then we have more interesting part of the workflow that is more related not to libraries but for applications. So staging for some extra testing, and finally we get to some really interesting stuff like Canary Releases, where we would put that new version of the application on one of the production nodes, not all of them, just one or few, it's configurable, and then we will start sending like real production traffic and monitor a bunch of things. The signals from the Canary testing is like hundreds of them, and you can also configure your own signals. And you can monitor all kinds of stuff like CPU spikes and memory spikes, if there are any new exceptions, if there are any business metrics that are going down for some reason. So all that stuff can be monitored, and Canary can be pulled off. The next phase, after the Canary release is successful, and let's say you rolled out that new version of an application to all the production nodes, we ramp up features. So all the features are hidden beneath that layer of experimentation framework. Sometimes it's called A/B testing or some like experimentation testing framework. This adds complexity, but it adds so much quality because we can really gradually ramp up features. The classic way of using that at LinkedIn is that we would ramp up pretty aggressively to LinkedIn employees. And there's 10,000 LinkedIn employees all over the world, most of them using LinkedIn apps and applications pretty eagerly. So it's a really good ground for making sure that we didn't break some things. It also ties back to this like new way of doing things. Like, I don't know if you have noticed, but over the past couple of years, like instead of like really making sure that you test everything up front and you get this like huge, gigantic automated test suite, you push a lot of that validation to the later phases, to the monitoring of the application on production, and also like slow, gradual ramping up features. This is working really well, and that also enables like really fast commit to production cycle. The last part of that workflow is to remove the experiment. So when the feature is ramped up to entire population, we want to remove the experiment, so actually the code has to be changed, which is another additional cost. And also in the past at LinkedIn, we've noticed that sometimes the old experiments, that little layer of conditional logic was not removed. So we added monitoring, and we actually know when the old experiments are not removed so that we can we can tell engineers to fix them, so there are tools for that as well. Now, this whole thing, 3x3 and continuously deliver at LinkedIn, it's really like created this like culture shift in engineering, because it really means that like the change that I'm doing right now, it has to be like really high quality, it has to work. I can't postpone anything. I can't postpone testing, documentation and stuff, it needs to work. And I need to know how to write tests really well. I need to know how to write production code really well. And that's pretty amazing. Like I'm super glad that we have embarked on that road mainly in 2015, and it was really hard to get there, but when we are now here, it's like amazing. It is not about technology. It does play an important role. Like if you try adopting continuous delivery and really like frequent releases, you'll notice that, oh, my test framework is just too slow or unstable. What do I do with flaky tests? Like you will have technological challenges how to solve certain problems. But at the end of the day, it's not about technology, it's about mentality. Like think about like every code changes the release candidates really have to be high quality. If you search for 3x3 on LinkedIn Engineering blog, you will find a lot of articles. So, and they will get into like further like detail, like and how we exactly did it for Android, iOS, and various other platforms. And this is our last slide. To reiterate, I started with Mockito, the continuous delivery journey, circa 2014. Now, ShipKit is a set of tools that basically make that workflow really simple. ShipKit closes this gap in the open source where I have my Java code and it works, but how do I publish it quickly without like setting a bunch of other plugins and configuring and reading how to do it? I just want to drop little Gradle plugin and just the magic happens. So this is ShipKit, and we've got a couple of contributors here presenting, and you can join the project too. Finally, LinkedIn and 3x3 was the last bit, like last part, and that's it. If you have any questions, you have to ask them later at the after party, or you can catch us. We've got awesome ShipKit t-shirts that you can grab from here. ShipKit, you gotta get your priorities right. First you get a t-shirt, and then you go 1.0 with your library. That's how you do it. And thank you guys.